Let us look at the 2019 paper 2 mathematics, that is for GCE question, and in particular we want to focus on the vector question. That was question number 3b. So this is the question that we are going to look at, and we're going to practice how we can answer vector questions in the exam. So up to this point, if you are part of our online classes, we've learned enough on vectors and how to add vectors, how to represent vectors, how to subtract vectors, and how to complete vectors by using the triangle law. So all the things that we have been learning, that's the ones we are going to use to answer this question, and let's see how we can do it in the actual exam. So right now we have this question and we're going to answer it. Let's use the things that we've learned in our lessons to answer such questions. So the question states that in the diagram below, OA, vector OA is equal to A, and vector OB is equal to B and B underline, and AC divided by CB is the same as 1 over 2. Okay, AC divided by CB is equal to 1 over 2. So you need to pay attention to this here, because such information is what we'll be needing or we'll be using to answer some of these questions. So AC divided by CB is equal to half. So take note of that. Okay, that is good. So let's check what we have here. So we have O to A is equal to A underline, and we have OB which is equal to B underline, and what else do we have? Okay, I think for now we have that. And now they want us to express in terms of A and OB, express in terms of A underline and OB underline, A to B, vector A to B. So vector A to B. So up to this very point, I think we can now use what we have studied so far in our online classes to answer this. So just a sneak peek of what we did in class. So these are some of the things that we mentioned when we were in class: how to add vectors and how we can use what we call the triangle law. So if you are not part of our online class, you can probably find a link or the line below to join the classes. So that is how we say we should add vectors and how we should use the triangle law. And when it comes to vector subtraction, we said how we can subtract two vectors, that is by reversing the sign of the vector or the direction of the vector. If they're pointing in the same direction like we can see here, then that means we have to reverse one of the vectors so that it points in the other direction, so that we can complete the triangle. And we said vector subtraction is just vector addition, whereby we reverse one of the vectors. So getting back to the question, so how do we use those things that the principles we've studied to answer these questions? So express in terms of A and B the vector AB. So you look at the vector. If it's vector AB, then starting from A, it's going all the way to B, like that, in that direction, A going all the way to B. And for us to complete the triangle, remember we're using the triangle law. For us to complete the triangle, we have to go in some specified direction. So if we are starting from A, going to that to B, this is this third, which means that we are starting from A, we're going to B, and to complete the triangle, this is the third side of the triangle, which is AB, and then we have the vector from A going to O, okay, from O all the way to B. So we have to go in this direction, and everything that is opposing this direction, that means we have to flip it. So when we start from A going all the way to O, we are seeing that we have A underscore here, but this vector is in the opposite direction. It's going in this direction. It's going in this direction. Now, in order for us to complete the triangle, we need it to be in the opposite direction. So that means we're going to force it to be in the opposite direction by changing the sign from a positive to a negative. So this will be like that, because if we want to find the vector AB, then we have to add the vector AO plus the vector OB. That will give us the vector A to B. So we see the vector OA, we don't have OA, rather we don't have AO, sorry, the vector AO, we don't have it, we have OA. So how do we get AO from OA? So for us to get the vector OA, we have to flip the sign or to change it. So this, instead of being vector A, it now changes to negative A underscore plus underline, sorry, plus OB, which is the vector from here going to there, which is B. This should give us the vector A to B. So just swapping them, we have the vector A, B is equal to B underline minus A underline. That is the vector AB. That is for the first question. Okay, so we have A. We've just swapped A. We've reversed the vector OA to make it AB by changing the sign here, so that we can easily complete the square like we did in class, and how to complete the square when we are doing vector subtraction. So I hope that is understood. And we got to the vector AC. Find express in terms of A and OB the vector AC. So again, let's just get rid of what we have here. So what is the vector AC? So AC, we are starting at A, we are going to C. Okay, so this should be in this direction, AC. So it's starting from here, goes to there. And then again, we're trying to look at situations which can give us a triangle by using the triangle law for adding vectors. Okay, so AC is made up of, to make a triangle, we've got OA, AC, like that. Okay, we've also got the vector OC there. Okay, so at this point, this is where we use ratio in the grade 7 ratio. Yeah, so I hope you remember the grade 7 ratio we did. If you don't, you have to go back and revise, because this will give you a little bit of problem to find the vector AC. Because as you can see here, they've given us a ratio here that AC over CB is equals to 1 over 2, or we can write it in ratio form that AC to CB is equal to 1 to 2. So which means that if we want to find AC, the vector AC is equals to 1/3 of the total vector AB, which we found that to be AB, B underline minus A underline. So this will be B underline minus A underline. So that is this is AC. Okay, so we follow the ratio that we have here. So we have AC to CB is 1 to 2, like what we have here. So the vector AC is equals to 1 of the total, and the total is just 1 plus 3 plus 2, sorry, which gives us 3. That is 1 over 3. Multiply that by the total vector, which is from A to B, and we found that to be B minus A. So this is the vector for AC. That is AC. The vector AC is equals to B underline minus A underline divided by 3. Okay, so that is for this one. expressed in terms of A and or B, the vector OC. So the vector OC, it is this one right here. So now that we have the vector, you can see that we can complete the square or the triangle, sorry, from here, or going all the way to A, from A going all the way to C, right? So by completing the triangle, we can just use this one here. So it is basically addition of vectors. We are adding the vector OA, so the vector OC, according to here, the vector OC will be equal to the vector OA, plus the vector AC. So what is OC? So OC will be equal to the vector OA, or A, that's A underline, so A underline, plus the vector AC. AC, what is it? It's this one here, which is 1/3 multiplied by B minus A. Okay, so it's underline. So from here you can see that what you have now is we can expand, we can multiply the we can expand so that we remove the brackets, so to be plus 1/3b underline minus 1/3a underline, putting the like terms together. So allow me to create some space by removing which one I'm going to remove this part here. So if you want to refer to it, you can just play back the video. Alright, so if we put the like terms together there, that is coming from here, we put the like terms together, we're going to have A underscore minus 1/3a underline plus 1/3b underline. And then from here we can see that the vector from here, A minus 1/3, we can just combine this to be that is 3 as a common denominator. We can just say this is over 1. We're adding 1 to so we are subtracting A minus 1/3, which basically I think you can just do this math. That is 1 minus 1/3, that gives you 2/3, right? That is 2/3a underline plus 1/3b underline. So this will be the vector OC. If you want further, you can pull out 1/3 as the common factor there, and then we just remain with 2a underscore plus b underscore, like that. So this is our vector OC. Okay, in this form, this is our vector OC, which is 1/3 2 times a 2a underline plus b underline. Okay, that is how we find questions 1, 2, 3. So given that the second part says, given that M is the midpoint of OC, show that the vector AM is equal to 1/6b underline minus 4. Okay, is equals to that. Can we show this, or we right now, or we got the next video? Okay, let's see if we have enough time. Okay, so it says, given that M is the midpoint of OC, show that AM, the vector AM is equal to this. And okay, so what we have here, we look at this OC, which is the vector, which we found it to be this one right here, and we want to find the the vector AM. So given that M is the midpoint of OC and OC is what we have, so if M is the midpoint, that means the vector, we'll need the vector OM and MC, and these whichever vector we choose, we can use any of these to find the vector AM, because if you look at the vector AM, we're coming from A, we are going to M, so that will be the direction there, A to M. And then if you look at this direction here, we have the situation when we said the vectors are kind of meeting at this point, and hence it's difficult to complete a triangle using a triangle law. So we have to flip particularly this vector so that it goes in that direction, or we will have to flip whichever vector is suitable to be flipped. It could be this vector or it could be that vector, but I'm going to choose one of these vectors to be flipped so that we can make these, we can actually try to prove that the vector AM is equal to what we have done here. So let's see if we can prove this. So we have the vector OC, and then they give us that the vector, let's try to get the vector. So here we have the vector, we can use any of the vectors that we want. So we can also use the vector AC plus CB should be equal to AM to prove the vector AM. So for us to do that, we'll need the vector AC to add, we will need to add the vector AC to CM, okay, to give us the vector AM, and hence we complete the triangle. But again, when we look at the vectors, we only have the vector AC, which is this one here, and we don't have the vector CM, but rather we can find the vector MC, which is half of the vector OC, because we have OC, and then we need to find half of the vector OC, that will give us the vector MC, and then we need to flip that vector to give us CM. Okay, hope that doesn't sound really complicated. So what we have to do is we have to find first what is the vector MC, because as it stands now, it's pointing in this direction. If we find the vector MC, it's pointing in this direction. So we can say the vector, if the vector AM should be equal to the sum of the vector AC plus the vector CM. But the thing is that we do not have this vector CM. So how do we find the vector CM? So the vector, what I'm going to do is I'm going to need some space, so get rid of some of the things that we've already written down. So since we're going to need the vector AC, I'm going to get rid of the vector AC. I will need AC and OC. So which vector? I'm going to get rid of this. I think we can find this from you can just replay the video if you want to know how we got the answer there. All right, so next what I'm going to do is that we're now going to find the vector CM by first finding the vector MC, because we have, remember, when it comes to vectors, they're defined by direction and you have to maintain that direction. So the only thing that we have here is OC, so it's going in this direction from O to C. It's in this direction, and then they've told us from this information down here that M is the midpoint of OC. So if M is the midpoint of OC, that means half of this vector, so is equal to MC. So we're going to multiply the vector. So we'll say the vector MC is equal to half times the vector OC, or half the vector of OC. So you ask yourself, what is the vector OC? The vector OC is equal to 2 2a plus b divided by 3, right? Which is from here. From hope you can see that this was I hope the screen is so the vector OC, the vector OC was equal to 1 over 3 2a plus b. That was the vector OC. So we're going to multiply this vector by half, which is this one, and that will give us 2a plus b over 2 times 3, that is 6. Okay, that is 6. So this is the vector MC. So if this is the vector MC, how do we get the vector CM? So we simply change direction by multiplying it with a negative. So allow me to get this on the other screen because this is kind of getting a little bit rusty, I think. So this is what we have, and we can find the vector. I'll put it down here. So we can find the vector MC. We need the vector. Since we need the vector, we said the vector from, if we wanted to, I'm sorry if this was out of screen. I didn't notice that some of the letters were off screen. Sorry about that, but I'll try as much as I can to re-put them or rewrite them in a way that we see what was going on. So this is AC plus which is AC plus CM to give us the vector AM. So this was supposed to be AM. So we said AM, the vector AM is equal to the vector AC plus the vector CM. And then we said that we found the vector MC, but we need the vector CM, so we need to change direction. So the vector MC, we found that to be MC is equal to this. So I'm not going to write it because of some time. We just have to flip it. We have to flip the MC to become CM. So we'll introduce a negative, and then this will be 2 over 6, not 2 over 6. That is 1 over 6 multiplied by 2a underscore plus b underscore. Okay, now this is down there. Okay, so this is now the vector MC. If you want to make it the vector CM, then we have to introduce a negative there. This becomes negative 1 over 6 2a plus b. And then we say, okay, so now we have the vector CM. We can now find the vector AM by adding this vector, which is AC. What is AC? We said the vector AC, we found it to be here, which is this one, which is said 1 over 3, which is 1 over 3 multiplied by b underscore a underscore, then we have the brackets there, plus the vector CM, which is this one, which of course is a negative, so we won't need this plus here. It becomes a minus, because positive times negative becomes negative, so it's negative 1 over 6 times 2a plus b. Okay, so this we need some work, so let's go on this another screen and we do it from there. This is we're trying to see what this vector, which is AM, what it's going to give us, because the question said, well, let us show that the vector am is equal to this. So let's see if what we have will give us this. Okay. So getting into it here, we have to expand the brackets. So this is going to be 1 over 3b minus 1 over 3a minus 1 over 6 2a, okay, underline minus, not plus, because we have got, so remember here we have that one there, so the bracket, so this is nothing, so we have got negative 1 over 6 times b, which is negative 1 over 6b, or if you want you can say negative b over 6, whichever way you feel like it's comfortable for you. Then we're going to get the like terms together. That means put like terms together. So I'll get the a's here. So I have negative, I'll just say negative a over, let me just continue it. So we'll just say negative 1 over 3a underline minus 1 over 6 2a. Okay, so from here we can, okay, 2a, then we go to negative 1 over 6b underline, and then we have positive 1 over 3b underline. Okay, so we've collected the like terms together. Now let us work on them and see what we have. So okay, from here we can say this is negative 1 over 6 times 2 2a, so we can cancel this 2 here and 2 there, okay, so that we find the common, so what we get here is negative 1 over 3a underline, this becomes minus 1 over 3a underline, okay, and then becomes minus this here, we say negative 1 over 6b plus 1 over 3b. We are just subtracting here because we've got a negative here, a negative value there. So what should be the answer? So here, so this is paper 2, so you're allowed to use the calculator. So you can make use of the calculator on subtracting or adding fractions like this, and then see what you get. So what we have here is negative 1 over 6b plus 1 over 3b. The answer should be what you gave us. This is going to be positive 1 over 6, okay, positive 1 over 6b, okay, that's going to be an answer. And then you can verify this, okay, so negative 1 over 6 plus 1 over 3, the answer is 1 over 6, positive 1 over 6. Then here we've got negative 1 over 3a minus 1 over 3a, so we just could have to add this, and we have negative 1 is 2, not 1, so the negative 2 over 3a, and then we say plus 1 over 6b. Okay, so this is the what we get as the vector am. But then let's see if this vector will prove can be the vector that we want to show. That am can show that the vector actually is this one, this vector we have there. So that is what we want to show them. That one there. Okay, so let's not get tired. Let's look at how we can do this. So we can we can add this. Okay, so we'll say, okay, so I think we can get rid of this part. We can just demarcate this by that, then put it on this side, and then we can say negative 2a over 3, and then this is plus. Okay, let's just do it directly from here. So we can find the common denominator. There are 3 over 6, common denominator 6, and then we say 3 into 6, that is 2 times negative 2, that is negative 4. Okay, so that is negative 4a, plus 6 into 6, that is 1. 1 times b, that is b. And then we say okay, so from here we can see that we can this becomes okay, that is where we need to understand a little bit of a trick. AC is equals to 1 over 6, and then we say this is we are bringing the 6 just on this side because it's common on this side and that side, the 1 over 6 because it's common. So here we remain with negative 4a and then plus b. Okay, now here we see that what we have in this equation actually is b minus 4a, and here we have minus 4a plus b, which is, we've already done it, we've proved. So the only thing is just to rearrange 1 over 6 is equals to b minus 4a. Okay, so this is the proven equation of vector. So the vector am in yellow there is 1 over 6 b minus 4a. Okay, and then we have underlined there, which is exactly what we have here. So we've proved that the vector am is equals to 1 over 6 b underlined minus 4a underlined. So how have we done that? So was some work involved, kind of the work. So we just had to find the vector. We said the vector am on this part here, we said the vector am should be equal to the vector AC plus the vector CM. And then we said we have the vector AC, which is this one here. We added it to the vector CM, and then we found the vector CM by finding the vector MC and flipping the vector MC to give us the vector CM. So we did two things. We found the vector MC, flipped the vector MC to give us the vector CM by introducing a negative there. And what we did is we just found now these the vector AC plus CM in this equation, in this part here, and then we completed the addition of vectors here just by using the addition of fractions. We came this way, we simplified, and we ended up with am is equals to 1 over 6 b underline minus 4a underline, which is exactly what we have in the paper there. Okay, so that is how we answer vector questions. So mostly you have to think about the triangle law in whatever you're doing when it comes to vectors. That will help you a lot to find vectors. So the other thing you need to learn or revise ratios. They will help you to answer such questions. The next thing is the addition of fractions. Okay, fractions, you need to know how to add and subtract fractions, because for such questions you need such knowledge. Okay, so it was a lot of work to do, but I think at this point we've done it. So that is how we answer this question. So we've answered 1, 2, 3, and 4. So we'll see you in the next video.